So I'm Jesse. This is the Wolfram Summer School live coding competition. I'm having my own little behind-the-scenes stream here where I'm going to be showing you the answers as contestants submit them and going over them with the goal being it's understandable for someone who's not necessarily too familiar with the Wolfram language. So the live coding competition has already started. I think they're on the they're still on the first question. So I'm gonna jump over there and show you the question. So Stephen Wolfram is streaming the live coding competition too, but the answers are not visible there. So I'm gonna bring up his stuff here. So this should be his screen. Just make sure that okay. This is his screen right now, and you can see we're on problem 1, odds before evens. I wrote this problem actually, and the question is reorder the provided list so that all the odd numbers are placed before the even numbers, but the relative order of each set remains unchanged.
It's great to see
and
a
I think you can probably hear Stephen right now. I'm just gonna hold on a second. Just going to mute. Mute him. Okay. So I'm going to look at the solutions that we have here so far. Okay. So the question is here. We're going to scroll up. Ooh, what's this? Okay. Anyways. Question is here. I'll actually open up my. It's not on here, is it? Okay. So yeah, the question was sorting the list so odd numbers are before evens. The solution that was given here is flatten gather by list odd q. What gather by does is it gathers into it takes as the first argument a list of any value, and as the second argument it takes a function, a pure function that should return a Boolean value, so true or false. And what it does is for each of the values in the list that it receives, which is this list here, it applies that function to it, and if it's true, it puts it in one list, and if the result is false, it puts it in another list, and then it returns those two lists together as a list of two lists. So I'm gonna jump over here. Should see my screen. Okay, so I'm going to just make really a list of random integers from -10 to 10. So it's just these integers here. So if I do gather by, and the function oddq that was shown there is tells you if simply returns a Boolean value if a number is odd or not. If it's odd, it returns true. If it's even, it returns false. So I'm going to try gather by here with list and odd q. Okay. Okay. So as you see here, we get two lists with two sublists. The first elements here are what is returned as what's false. So let's see. So that's the even numbers, and I think wasn't the question. Okay, yeah. So why are the odd numbers? Let me get another list with some. Oh, okay, I'm sorry. I should have done from -10 to 10 and then get 10 random integers. Sorry. So here, we'll gather by that. And okay, there we go. So the odd values are first here, and the even values are second. So it returns whatever returns true for this odd q goes in the first list, and whatever returns false goes in the second list. And then the second part of that result, flatten. All that does is it takes a multi-level list. It can have however many levels, and it just flattens it down to a single level. And gather by sorts these. It maintains the relative order of these. So we don't have to do any kind of sorting or checking to keep them in order. Gather by maintains the relative order of these to each other. It just moves the even ones with odd q. It moves the even ones to the end. So that's the given result there. So I'm gonna. It looks like they're on the second question now. I can see I have the live coding chat up here, which has the questions as they're coming in. So I can go over here and see. There are any. It looks like there aren't any results in yet. But okay, then I guess I'll go back over here. The question: use the pixels of the provided binary image of the U.S. as the initial condition for the game of life cellular automaton, and return its 50th step as an image, a Wolfram language image object. Treat black pixels in this image here as filled cells, and white pixels as empty cells, and vice versa. So filled cells as black pixels, and empty cells as white pixels in that other part. Okay. Let's see. Let's go over this. I imagine some people might not be familiar with cellular automata. Cellular automata are something that Stephen Wolfram is very interested in and has studied very thoroughly. And they are one of the first concepts presented in his 2002 book, A New Kind of Science, which talks about computational science and complexity in the computational world. Okay. So a cellular automaton is a rule. In this case, we're cellular automaton is a system that takes values and transforms them based on a specific rule. This particular kind of cellular automaton that the game of life is, it takes a value, it examines the neighborhood of a value and determines the subsequent value to be produced based on rules that apply that neighborhood. So we can see here, actually, I think I'll just use elementary CA 30. That's one of Stephen's favorite rules, I believe. So I think that's just going to give you a, okay, well, rule plot. I can do a rule plot of cellular automaton 30. Here, which will give me this plot here, and then I can plot out cellular automaton rule 30, and the syntax for this function in the Wolfram language takes the rule number, and then the initialization state, and then the number of steps to evolve it for. So I'm not sure if I remember the syntax for the initialization state, but I think we have a 1 there, and then say 20 steps, and then I'll feed that into array plot. Nope, that's not right. Oh, it's 1 and 0. Okay, yeah. So we start with that 1 there. We're starting with a single black cell, and then we simply follow the neighborhood of that cell. Follow these rules across that neighborhood. So we'd start with a single black cell. Let's just maybe do 5 steps to make it easier to see. So we start with a single black cell. We can see the rule here that applies to that is this one. So you get a black cell as the result. So the one directly below it ends up being this this black cell here. For these 2 cells, which are white, but we still follow the rule on them, this one has its neighborhood is black, white, white. So black, white, white gets a black cell, get one below there, and white, white, black. So for this cell, also gets white, 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 black. You get a black cell below, and then this rule is just followed for every cell in every row procedurally. So for this one here, black, 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 we get a white cell below it. This one, white, black, black, we get a black cell below it, etc., etc. And the interesting thing about even these, there are many types of cellular automata, but even these, there are 256 so-called elementary cellular automata, which mean they are one-dimensional. Their rules look like this. They're that simple. But the amazing thing is that you can get some really incredible looking patterns out of this. So something like 50, even with just this simple rule, you can get, oops, it's only the array plot. Capital B. Okay. So even with this, you can get some incredibly complex looking rules, and if I go up to something like 200, you can see the complexity continues. It doesn't stop. Not all of the elementary cellular automata are like this, but this one, at least, Rule 30, is one of the most really incredibly striking. Another one is Rule 115. No, not 115, 150, sorry. 150. Okay, there we go. So Rule 150 isn't as strikingly random looking, but you still get complex fractal-like behavior out of it, and still from just these simple rules. The rules are a little bit different for 150. But still, it's the same level of simplicity. So cellular automata are really kind of amazing. If you're interested in them, there's a lot of stuff to read on Wikipedia, or of course the website for Stephen Wolfram's book, A New Kind of Science. I believe the website is wolframscience.com, and you can read the whole book there for free, and goes into lots of complex systems beyond cellular automata. But these elementary cellular automata are really my favorite complex system, I think, because they're just the rules are so simple. The game of life cellular automaton, which is mentioned here, is a little different, but it's still quite simple. I believe if I give game of life here, I can get the rule plot for it. So it's a little different. It's a two-dimensional cellular automaton. So the neighborhoods that it looks at are two-dimensional. So it looks at a given cell and then the 9 adjacent cells, I guess. 1, 2, 3, 4, 5, 6, 7, 8. Oh, the 8 adjacent cells, and then the one in the center, so 9 cells. But it's still, and it also operates in each of those. It looks at the value in it, so it's not just binary 1 or 0. I think there are. Oh, I'm not sure. I think there are seven possible values in there. I'm not quite sure about that, but in any case, it's still really quite simple. So what this question is asking is to use the pixel values of this image. So all the ones, actually white is 1 in an image, so the ones up here and the zeros down there as the initialization conditions. So the start at step 0 of the cellular automaton, starting with those as the initialization conditions, and then evolving it the same way that it does one of these, and evolving it to 50 steps and returning the 50th step as an image, a Wolfram language image object. So you have to use the function image data, which gives you the pixel values for each of the pixels in the image, then pass that into cellular automaton, and then go back and imagify that, turn the result there back into an image. Now there are two similar things that will trip you up, that could trip you up about this. So let's see, image data, as I'll just copy it from the chat here. Image data, that's not right. Image data. Okay, well, hopefully I can copy the image. Okay, there. The image data of this image, it's going to be the result is going to be, return value is going to be a little bit big because it's it's like 200 by 300 or something like that. But let's hope I can show a bit more of this. Okay, so what image data looks like, since this is a two-dimensional image, you get a list of lists, so the rows and columns, and then, okay, and it's a binary image, which means each pixel can be either on or off, 1 or 0, black or white. And the thing about images as they're represented here is 1 corresponds to white and 0 corresponds to black. But cellular automaton, the function, it treats, there really isn't the concept of black and white here, but the corresponding thing is that it treats 1 as black, a filled cell, and 0 as white, an empty cell. So what you have to do here is color negate this image before you pass it into cellular automaton. Color negate the image, and what that does, it's a function that just it converts all black pixels to white pixels and all white pixels to black pixels. So if I actually just color negate the image, you'll see that it's just the negative of that image, black pixel or white pixel to become black, and black becomes white. So when I pass that into image data, it's again ones and zeros are just swapped. You can trust me on that, so I don't have to expand this. Okay, so once I've done that, I can go and pass that into Cellular Automaton. So I do Cellular Automaton, and the rule Cellular Automaton has a nice thing where some very well-known Cellular Automaton rules, you can just give it the string as the rule value instead of entering the actual, like, the code for the rule. Like the numerical code for the rule. So I can just type game of life here, and it knows the rules for that. And then this image data value here, I believe that's I hope I don't have to change anything else, but that should be the value of the correct format for the initialization conditions. I think that's right. And then here, if I say 50, then it knows I want to evolve it for 50 steps. And then I can pass that into array plot, which is kind of like image, but it doesn't rasterize it into an image. It just returns a sort of graphics object. So if I do this, I should be able. Oh, that's not right. Game of life. Let me check something. Hold on. Okay, oh yeah, I think array plot expects something different from that. Okay, yeah. What it's going to do here is it's going to evolve it for 50 steps and give you all of those as a list for each of the steps. So what I want to do, I could do parenthesis 50 parenthesis. That would give me just the 50th step, but it would still be in a list. I could get the first element of that list since it's a single element list, but even easier is just use 2 brackets here, and that should give me, I'll evaluate this to, yeah, that looks right. So array plot of that should, oh, okay. I think I need 3 parentheses. The number of steps, the step specification for Cellular Automaton is a little weird, but that should, I hope that one works. I mean, okay, yeah, so I'm kind of trying to solve these just like the participants. So here, we've evolved this with an array plot, and it looks like you can see here, this person here appears to have gotten the, that's one of the winning solutions, one of the top 3. It looks exactly the same. You can see it's the same, and you'll notice if I don't color negate it first, it doesn't look quite different, but it's still different because those rules, it's applying the rules that should be applied to white cells to black cells and vice versa, like that. So that's why the color negate here is important, and that's also why the question says treat black pixels as filled cells. If you didn't color negate, it would treat black pixels, because they're 0, it would treat them as empty cells. So that's why the color negate here is pretty important. Okay, now I want to make this. Color negate of the image. Now the question doesn't tell me to return an array plot, though. It wants me to convert it back into an image. So now that I have this, if I could just pass this into image, but you'll see immediately that you get it, but it's inverted. That's because the remember that array plot, like Cellular Automaton, treats 1s as black and 0s as white. But what image does, for the same reason that we had to color negate it here, image treats 1s as white pixels and 0s as black pixels. So what I have to do here, since I can get an image out of this, image at, you see using at here, that's just a shorter form of putting the square brackets around the whole thing. It's the same thing. It's for calling a function with one argument, and the / at the end I did here, image, that's just the same thing just happening at the end. So I get this image here, so all I need to do here is just flip the colors back. So color negate this again, and I'll get a result from here that looks good. It looks like what the participants are getting. and I don't know if they have the top 3 yet. We can perhaps, let's go over to see what's happening here. I'm switching over to, is this working? No. Okay, I need to unmute it here. So,
this was the version suggested by the original.
Okay, yeah, so there, that you can see the solution there. And it looks like they did get those top 3 solutions.
That's interesting. And so it color negates to make the
okay. So Stephen's basically explaining what I was just talking about. Color negating it first, then getting the image data.
And then it's
I don't know if this is distracting having me and Stephen on at once. Is that a problem, Danielle?
Getting the image of that, and then
having me and Stephen on at once, is that a problem? Okay.
Okay.
So yeah, he's explaining that, and you can see this is the same solution that I wrote over here. But you can see the participants. Some participants did do it differently. I'll jump back over here. Except I want
within its rights.
Okay, back here. Okay, so this one here, okay, that's interesting. They're passing the rules for Game of Life manually instead of using the string method that I mentioned, but that's also totally valid. It's the same rules, so it's fine. But they're doing image data of color negate. That's correct, but looks like, and they're doing the 2 square brackets. So, and what that does just return a list that has just that step in it. And then they're just doing first to get that out. That's totally valid. But then they're doing array plot. Now the question asks for for it to be returned as an image, not an array plot. So, okay. Well, yeah, the question asks for it to be returned as an image object, not an array plot. So that one actually shouldn't. That doesn't quite follow the question requirements. This one does array plot too. They use Game of Life here. And that's essentially equivalent in how they're specifying the initialization, or is that right? Yeah, I think that, yeah, that's essentially equivalent in how they're specifying the initialization conditions, except I think that would allow it to expand, because they're saying what this 0 here means, it's a list and it has the initialization conditions, and then the 0 means that the background will be treated as white. So that might mean that it'll let it. Yeah, this one lets it continue beyond the boundaries of the resolution of this image. So that one's also that's not exactly correct. That's not really what the question asks for, because it says to use the image as the initialization conditions. But I can understand that that's an understandable misinterpretation, and you can make the argument that it's valid as well. And then let's see. Well, these don't have the output cells. This one, yeah, this person. Okay, this is the person that did that, and that's pretty much the same. But it's still getting the outside bits here. That one. That looks like that's the question that was. That's pretty much the correct answer there. So that one does look correct. Anyways, gonna jump down. It looks like they're at another question here. So let's go over and see what they're up to. And let's see. So oil density. Calculate the top 10 countries by their oil reserves per unit of land area. So it's not the density of oil as a chemical. It's the density of oil within a country. So how dense the country's oil reserves are relative to their land area. And you can see land there is bolded. That's probably because the question designer wanted it to be clear that the question is asking for the land area, not the total area of the country's borders, because the total area of the country's borders would include bodies of water that are inland within the country. So they did specify there you want land area. So looks like there are. I'll go here. There are solutions coming in. I'll just look at these. So let's say, okay, this one here. Okay, this one, I think this is the first one to come in. So they're using entity value, country, oil reserves, land area. That's correct. These are essentially equivalent. It's just what entity value does. Let me. What entity value does is it retrieves the Wolfram language's values that are, they shouldn't be blue, but it returns the values of a Wolfram language entity, or when you pass it just the string country here, it returns values for all of the country entities that are within the Wolfram language. And then here you could give it just an entity name or an entity object here as the second argument, but if you give it a list, it'll return the values for multiple entity properties. And this one here, this is an entity property object. If we take a look at the input form of this, you can see it's just, this one's, we can see that it's an entity property object. It's just formatted nicely here. And then that one, land area, it's a string that's also referring to the entity property. It's just another way to do it. You can give it the string or the entity property object. And then entity association here, the third argument, which is not required, but when you set it to entity association, the return value from entity value is an association where the keys are the entities and the values of the association are the values of the properties. And in this case, since we specified multiple properties, it's a list of those property values. So if I just copy this here and run this on its own, my internet here should be good. I think I can actually disconnect from the Wi-Fi. And let's see. Okay, oh, there we go. So we can see the key, this is an association, and the keys are the entity, the country entities, so these are all the countries that are, really all the countries in the world, and the values are lists of quantity objects, which are the property values for oil reserves and land area. So the quantity of oil reserves, the quantity that the oil reserves values are given in is barrels, or U.S. barrels specifically, so barrels of oil. It's a standardized unit. And then the bit here, land area, that's given in an area. So that's miles squared. Actually, if you were on a if you are in a country that uses metric, and you're on an internet connection where the IP is Wolfram language can identify that as being in a metric using country, it would return kilometers squared. But here, since we're in the U.S. right now, it's giving miles squared, and the question does specify you want. Oh, okay, sorry, the question doesn't specify a unit, because it's just the top 10 countries, and it's a list of country entities, so the result, we don't actually want the value here, we just want them sorted by these values. So what this solution here is doing, they're doing delete missing. What that means is delete all of the key value pairs in this association where any of the values are missing. And normally delete missing would just do ones where the value is missing, but in this case it's a list of two values, one or both of which might be missing. So this specification, these arguments here, the one for delete missing says delete, so okay, well the 2 says look at level 2 of this association, which means the values within each of these lists, and then delete at level 1, which is the key value pairs. So so it's going into each of these lists, and if either one of them, if there's a missing for either of the values in the list, it deletes the whole key value pair. So that's just saying, that's just ignoring any countries that have where either of these values are missing, because we can't do useful computation with that. Okay, next, so they're doing apply divide. Okay, that's an interesting way to do that. I believe there's actually a shortcut that could be used there. Apply, okay, so this is fairly simple feature, but it's map, which means apply a function to each element of a list, or in the case of an association, apply the function to each value in the association. And then apply here, what apply does is it it takes a list and uses the elements of that list as arguments to a function. So, and the person here is using what's called an operator form. Normally with apply, you would do it like apply, and you can see here, you give the function first and then the expression, and there's a shortcut you can use these ats, but the apply function, you give the function that you're applying to each of the, the function that you are applying the values to, and then here for expression you would give a list of values to be used as the arguments. But this operator form here, they're doing apply divide, so that's basically saying apply divide, which is itself a function that just divides a number by another. So apply divide mapped across this array here would, for each of these lists, it would take the list and use the elements of the list as the arguments for divide. So dividing the number of barrels by the area. So I believe another way they could have done this is, instead of using the operator form of apply, they could, hold on, I want to copy the right thing. Okay, they could, so this one here, we should look at the output of this. If I evaluate this, take a little while because it's, the internet here is it's calling out to the external Wolfram servers, Wolfram Alpha entity value servers that have the oil reserves and land data information for countries. Okay, here, so we got this result, and you can see it divided the number of barrels by the area. And because they are Wolfram language quantities, so it's not just a number of barrels, but it's not just an integer. It's a quantity, which means it's a number that has a quantity, a unit associated with it. So when you do that, the cool thing about that is it's able to calculate, if you're dividing barrels by an area, that it knows that you want barrels per mile squared, or per kilometer squared. So you get out here this quantity, where the unit is US barrels per mile squared. So that's a very useful feature of Wolfram language. You don't have to look up the conversion multipliers for different units. It's all built in. And when you use entities, it gives you a quantity as your result by default. So you don't even have to worry. Really, you don't have to worry about what unit your value is in, because you can also convert between quantities on the fly within the Wolfram language. So here we have these great values here, but you can see the association is still, it's in alphabetical order, just like this entity value thing gave. So what we need to do now is what they do here, reverse sort. So it'll sort these key value pairs by the value. And what reverse sort does is, there's a function called sort, and what sort does is it just it sorts by the value if you're applying it to an association, but it sorts in ascending order. So the lower values will appear first in that list, and then the higher values will appear next. You could do sort, and then you could reverse that, but then there's just a utility function here called reverse sort, which is really exactly that. It does sort, and then it does reverse on it. And the end effect of that is that you get it in descending order, which is what the question here asks for. Or specifically it says top 10 countries. So that's essentially what it asks for. So we can do reverse sort of this, which that's what they're doing. And then this is part specification, so it's saying get the 0 here is, the 1 here is implied, so it's saying get values 1 through 10 in that list. And since it's sorted, those are going to be the top 10. And then keys here, that just gets the keys from an association. So an association is made of key value pairs, and if I just did this, it would be nice and sorted. Hold on. Hopefully it doesn't take too long. It will be nice and sorted, but it will still have those the keys and values. And the question asks for just a list of country entities. It doesn't want to know what the values, the actual barrels what the oil densities are. It just wants it to be sorted. So it's taking a little while, but okay, there. So you can see the top 10 here, and then if I do keys on this, that will just return the just the keys there, so the country entities. So you can see Kuwait, Qatar, United Arab Emirates, Venezuela, etc. And you notice here I'm using, the person who wrote this solution is using the land area property. That's correct, because it asks for land area. If I just did area, that would include, I'll give you some kind of example here. That would include some, okay, well, maybe, how about geographics? No, I'm sorry, I don't want I want geographics of USA. So it's just geographics gives you a map sort of visualization, essentially. Internet here is, it's doing, looks like the stream is going okay, but this is just taking, maybe it's because of all the other people who are also querying entity values. So if I had done if you do area here, it would do the area of the United States, but it would include the Great Lakes here, or at least those parts of the Great Lakes that are within the borders of the USA. While land area, and that it'll also include any like little lakes here, or ponds, or rivers, to the area, the border area of the United States. While land area is just the area of those places in the United States that are on land, so it excludes water area here. And it's questionable whether you'd want to use that for this question, because oil can be found underwater. But the question does ask for land area, and so it's important that you use the land area property. Okay, so just going to delete these, and it looks like they're on the fourth question now. Okay, calculate the shortest. I'll go over to Stephen to see what he's talking about. This up. I need to unmute.
Wireless microphone is.
Okay. Well, no. Okay. Okay. Not talking about much there. But well, get rid of that and back to here. Okay. So, U.S. tour. Calculate the shortest tour that visits all state capitals in the continental U.S. once and returns to the start. Return the length of the driving route following this tour as a miles quantity. So the length of the route as a quantity in miles, rounded to the nearest whole mile. So no fractional miles, no decimal. Okay, so shortest tour, what does that mean? The shortest tour, there's a function here which we'll probably see used by some people called find shortest tour, and that solves something called the traveling salesman problem, which is a problem in graph theory, which is and the object of that problem is to be able to calculate the shortest route that visits given distances between different points. So the shortest route by distance that visits a certain list of points exactly once and returns to the start. So so I could, I don't know, something like how if I wanted to go to California, Washington, and okay, chat. Yeah, I have it up here. Thank you. Divide. Yeah. So okay. So when for the previous, sorry to jump around, but for the previous question, divide at list. Why not use that? That's what I was saying when I said there is a shorter way to do it, a shortcut there. But I guess I forgot to show it. But what at does is it's exactly what the person with that solution somewhere in here. Anyways, what they did with apply, divide, and mapping that across a list, but at instead of just at for apply. At is map apply, or I think it's called map apply or apply map, something like that. But the shortcut is 3 at symbols, and what that does is it maps apply across a list. So it's a shortcut of doing apply and then mapping that across. So yes, that would have been a slightly shorter way to do it, and that's probably more idiomatic or elegant. But the result is exactly the same, since it's the same thing that's happening. Okay, so and someone asked, is this like an open forum where everyone is contributing, or just the employees? This is the Wolfram Summer School, which is a 3-week educational program at Bentley University in Waltham, Massachusetts. But the contestants here are made up of some students in the program and some instructors. So it's open to the students, and many of the instructors at the summer school are also employees. So it's open to the students and the instructors, but it's not at least not yet, not this time around, open to the whole wide world. You just get to watch. Okay, so back to find shortest tour, traveling salesman problem. So if I wanted to visit Alabama or California, Washington, and Louisiana. For those who may not be United States residents, Louisiana is in the south, sort of middle of the country horizontally. California is on the west coast, south, and Washington State is on the west coast, north. No, that's probably not a good example, since with just three, the route is the same either way. Louisiana, Washington, California, New York. If I started in, I'm going to sort of plot this around. It's backwards because the camera is backwards. But if I started in New York and went across the country diagonally to California, and then back up to Washington, and then to Louisiana, that would be a long route, because I'm crossing the country this way once, I'm going up, and then I'm crossing it, not all the way again, but I'm going. I'm doing a pretty long diagonal. A shorter route, I believe, I hope I'm not totally messing this up, a shorter route would be to start in Washington and go down to California, cross to Louisiana, and then up to New York. I hope that would be shorter. And that visits, and then return back to Washington. That visits each of those states once and returns back to the start. So that's what the traveling salesman problem is. And the find shortest tour here, which solves the traveling salesman problem for any list of a graph or any list of places, and you can give it a distance function option, which tells it how to calculate the distance between 2 points. Find shortest tour, conveniently, it can take geopositions just fine, and it automatically knows to use the geodistance function, which figures out the distance between, as the crow flies, distance between 2 points on the Earth, the sphere of the Earth. So we can see what people might be doing here. Okay, okay, so this person is grabbing all the continental U.S. States, as it says here, continental U.S., and is getting the capital cities of them, as the question requests, and then different one here. Okay, this one looks like a good response, a good answer. So getting all of the capital cities. Evaluate that, and this might take forever too, okay, capitals, okay, so these are the capitals of every state in the continental U.S., and I believe this is in alphabetical order, just like the states are by default. So Montgomery, I think Alabama would be first. Oh, there we go. Okay, Montgomery, Alabama, Phoenix, Arizona, Little Rock, Arkansas, Sacramento, California, etc. And then what I can do here is I can just take this list, capitals, and I need to do geoposition first, which gets the positions, the coordinates of those capitals. So I can say here, defining that to a variable. So that's just getting the geopositions of probably the geometric center of that capital, since the city has it's not just a circle, it has bounds. It's getting the I think this is so slow because everybody here is hitting these APIs as well. Ooh, it's not good. Okay, so pause is going to be a geoposition. When you give geoposition a list, it's going to return a geoposition object that is a a list of coordinates. So you could have a list of geopositions if you wanted, but this is a little. I think in theory this should be faster because it's sending them all of the capitals to the server instead of querying the geoposition of each of them one by one. It should be faster, and that's just, it's a geoposition list of points, and then when I can feed this into find shortest Tor. So Tor, find shortest Tor, and as I said, it knows if you're giving it geopositions, shortest Tor, it knows that you want it to use, or by default, that you want to find the geographic distance, the geodesic distance on the sphere of the Earth. So if I can just give it this, and this, since it's not going out to the cloud, it should be pretty, pretty fast, just a second or so. So this gives me two results here, or a list of two values. The first one, the second one is it's the Tor, but it's not those entities in order. It's the positions of those entities in that list here. So the indices of those entities in the list. But you can see we're starting with 1, which is Alabama. I believe it starts with the first one in the list by default. Then 8, I don't know what that is. Oh, it looks like people are getting. It's not quite correct, but people are getting stuff. But we can see it returns back to 1. And then this here is the distance of that Tor. So it's finding the shortest Tor, and it's telling you what the distance of that Tor is. It's finding the Tor that minimizes this distance value, and it gives you that value back. So this is in miles. So at first glance, that might seem great. It's exactly what we want. Just round that to the nearest whole mile, and that's the answer. And it looks like that's what this person here did. But this the question asks not the length of not the geodesic or geodistance of this Tor, but it's asking for the length of a driving route. So it's like as if you put it into your GPS. Put this Tor, these as waypoints into your GPS or your phone. And then it would calculate a route for you to drive, and also probably give you the distance of that, the length of that route. So we need to do something else here. We have this order, which is great, but we need to find a driving path there. So there's a function that's pretty new in the Wolfram language. I think it was released in maybe version 11.1 or 11.2 that is called travel directions, and that is it doesn't run locally, but calls out to the cloud, but it calculates the travel directions, by default the driving directions, to go from one point to another, or between a set of waypoints, and perhaps back to the first. That can give you all kinds of stuff about the travel directions. It actually has turn-by-turn directions, like turn left at Main Street, and then it also gives a geopath, which represents the actual path of that drive. But there's another function and it can also give you the distance of that, of course. There's another function though called travel time. That's basically, it's similar to travel directions, but it's just giving you the time to drive travel time is the time. Travel distance is the distance. So it's giving you the distance to travel that route. So it's easier than doing travel directions and then grabbing the distance out of that, or at least it's shorter. Now I will do this. It might take a little while because many people are using that as well. That endpoint as okay. I need to get, since this is just the indices in the list, I need to get the second element of Tor, which is this list of indices, and then from that list of indices, which looks like it's just this thing here, then I want to grab out from position, the geoposition thing. I want to grab each of those. Okay. Well, I guess then. Okay, I want the capitals. Well, actually, it's faster to do position value 1 with or element 1 from position, which is going to be we remember the geoposition as it's an object that represents that list of points. So element 1 from that should be a list of geoposition objects for single points. Yeah, so just coordinates right there. And so then I have this. Then okay, so then that's the coordinates in that order that's given here, and then I'm going to apply geoposition position to that again, which is going to give me another one of those geoposition things, but it's in that order. It's in that new order that's the shortest Tor. Tor pos equals that, setting that to a nice variable. And then if I do travel distance of that, as I said, it's hitting the API, so it might take a little while. And travel distance... oh, okay, so it wants a list of geopositions, so I have to map geoposition across there instead. So I'll get a list of geopositions for each of those coordinates. Okay. How's this work then? Okay. It's taking a long time, which is a good sign. So we should get in a little while, hopefully in the next hour or so, a result from this that is the travel distance, the distance to travel that path. Okay, there we go, 13,406 miles. And remember, they wanted it rounded to the nearest whole mile, so I'm just going to use the round function and apply that, not apply, but call that with that value there, 13,406, and I'll get 13,407 because it's rounding up to the nearest whole mile. So I think that should be the correct thing, and you can see what people are doing here is, okay, some people got the travel directions thing. That is correct, but then they didn't sort it into the shortest Tor. This person did do the shortest Tor, but then I don't know where that's coming from, but they aren't getting the travel directions. Let's see if anyone in here got the, that's probably not right, an area of 82 miles. That looks similar. Okay, yeah, they did find shortest Tor, but they didn't do the driving directions. Looks like same thing here. So it's important to read these questions carefully. It says a driving route, not a direct flying route, because you can't take your car on a direct route. And there were some visualizations up here. This is a direct route. Ooh, just scrolled down on me. But this one here is a direct route. Just copy it over. Here, they decided to make a visualization, which is cool, in addition to providing the answer, which isn't the right answer. But so you can see here, these are just straight lines connecting each of the capital cities, which is fine if you were flying in an airplane or a teleporter or something. Probably not an airplane, because they can't fly exactly straight. They have to count for wind and stuff like that. But this isn't what the question asks for. A driving route. So I actually don't see any that, this one is, that is similar, very similar, but they didn't get the continental. That's probably a good point, actually. They got the continental U.S. By subtracting Hawaii and Alaska from the U.S., which seems like that should be right, actually, but I think it's including Washington, D.C. Okay, and then it's okay then, because I'll check it, actually. But you delete this delete cases thing here. So if I'm right about this is going to include Washington, D.C., because that's in administrative division. Am I right about this? We have Washington. Oh no, I don't see it. What's the length of that? 48 states. Oh, that's correct. Okay, I'm wrong. It's not including Washington, D.C. So, what's wrong here? That's very interesting. Oh, no, wait, no, that's a different one. Wanted to go up to this one that got it almost right, but not quite. We have 13,000, so we want to find one that's, okay, 13,000 407. That one's right. That person got the correct result. That may be the first one here. That's correct. But there was another one that was 13,955. So I wonder what's happening. Wonder what is copy. Okay. Something's happening in here that's giving a slightly different answer. I'm going to figure out what it is. So we have travel distance. With coords as is it this? Yeah, this is the same one. So what's the result here? What are they defining to that? That's okay. List of coordinates, which I think is our coordinates is that's before we did that. So it's the geoposition thing. So we want to if we want to compare these, we want the first element of that, and that looks. These are the ones I see are the same values. If I check that equals cell 65, oh, it's okay. It's true. I have to do same Q equals. Yeah, okay. So at that up to there, it's correct, or at least it's the same way we did it. And with here is just sort of defining a local coords variable instead of defining it globally. It's a kind of a more advanced technique, but it's the person who wrote this might be something they're used to, which is fine. It's perfectly valid to use that. So defining a local constant actually, and then they're threading geoposition of that over this list. So thread is just it's sort of another way to do a map, but it's just the syntax. Ooh. I don't know what's happening there, but okay, the syntax for thread is a little different. It's just a different way to do it. Some people prefer it. It behaves a little differently. Alaska. Oh, they're right. Alaska is continental, just not contiguous. That is correct. The question should say the contiguous U.S. Then that is a good point. But okay. Through. So the thread here, they're applying geoposition to the last of find shortest tour. So they're doing the shortest tour just like. Oh. Okay. They are doing find shortest tour. Okay. So they're doing find shortest tour of these coordinates which are latitudes and longitudes. So that's treating it as if. I'm pretty sure that's, don't know too much about geographic, like map projections, but I'm pretty sure that's treating it as if it's like Cartesian, on a Cartesian grid, and Cartesian distances between the different points. And I'm just going to confirm that by running find shortest tour on this cell 65 here. And that's going to 122, yeah, that's a different one, and you can see the distance here is, it's in units. It's not, ununited values. It's just numbers, because it's treating this as if it's like you're giving it a Cartesian grid, and they're trying to find the positions there. But we want the geo distance, which is different because it's across the curved surface of the Earth, which is obviously different from a flat Cartesian plot. So I think that's the difference going on here. And that's why it's slightly different, because the difference between doing this on Cartesian and on a surface, a surface of a sphere, specifically the surface of the Earth, the difference, at least at these scales, is not that much, but it's enough, like not that much all things considered, but it's enough to throw off the values here, and it's enough to throw off the order of this tour. And what we end up doing there is we have the tour, and then we get the travel distance, and that's all nice. But it's still it's the tour. It's off at the tour point. So that is the that's what that person did wrong. It's very close to being correct. And if they were just changed up a little bit, it would be correct. But it's just a little bit wrong. And now, let's see. Okay, yeah, travel. Oh, now that's interesting. Now they're mapping travel distance across across the partitioned values here, so they're getting pairs of pairs of positions that overlap by 1 point, by 1 position. So they're like this. It's not just a pair and then the next pair. It's the pair and then the next pair includes the last element of the first pair. So that's this 1 here. That's setting that offset. But they're getting that, and then they're getting the travel distance from the 1 point of there to the other one there, and then they're doing across that, and then just adding it all together. So this person might not know that travel distance can take a list that has more than 2 positions. So you could get the list of as many positions as you want. So you can do all 50 states. But in theory, if they had done the find shortest Tor thing correctly with the geodistance and geopositions, and then that should still return the same result, the travel distance and totaling thing. It would just be rather a lot slower because it's sending those pairs 1 by 1 to the server that figures out the travel distance, or the travel directions, instead of sending the whole list at once. So it would be slower. But this person is close, and I think we saw one that was the closest. This person says this will work even if the default units weren't miles. That's true. As I mentioned, if you're on a European network or something, an internet network, you have a metric country IP address, then Wolfram language will, unless you override it, default to metric there. So use kilometers. So this person is they're unit converting to miles, which is fine, and then rounding it. And let's see. So that was they gave this one. That is that's correct. They're using the positions, the geopositions, instead of just the Cartesian coordinates that are actually latitude and longitude. So that one looks good. And Judge says it was first place. This one below here is second place. So getting the capitals, continental U.S. states. Now, what does continental U.S. states give? That's my. Is that does that include Alaska? I guess it would, since it's part of this continent. Okay, I want the entity list here. Oh, okay. Now that's interesting. That does not include Alaska. The continental, and this is a thing that's in Wolfram language. Continental U.S. states entity class. That is still just those 48, the 48 contiguous states. So they're treating, whoever set this up treats continental and contiguous as meaning the same one, same thing. So, and the length of that, just to confirm, that is 48. Yes, that's 48. Okay, so there is a rule in this rule book, rule sheet thing that was distributed to the contestants that says to treat the default Wolfram language interpretation of a natural language thing as the correct thing. So if I did here, if I say continental U.S. states, I will get this same thing here, the same value. So by the rules, even if it's not quite exactly correct, by the way the rules say it, that is the correct thing to use, even if Alaska is also continental. Okay, so someone said here, but also in both variants, find shortest Tor use geo fly distance, not drive distance. It may changes order. So you're saying you're using find shortest Tor on the as the crow flies geo distance instead of the driving distance. But the question looks like they're actually on to the next question by now. But the question is the driving distance of the shortest Tor between the states. So I see your point. I wish I could still see the question to figure that out. But I see your point that it's that find shortest Tor, you're calling find shortest Tor with the as the crow flies distance, but it's I believe the question said a driving distance distance of the shortest Tor, as opposed to the shortest Tor by driving distance. It's a very fuzzy line, but I see your point, and it's possible that that is an error, or at least a lack of clarity in the question. Okay, we're on to fifth question, gene music. Okay, take positions 1877 through 1882 in the sequence of the human gene SCNN1A. Convert each base A, C, G, or T in the sequence of the gene to its respective musical note. So the musical note A, C, G, or T in the middle C octave, treating T as the note E. So A, C, G, or E. Assemble the notes in succession, each playing for 0.3 seconds using the piano instrument, and return these as a sound object. So Wolfram language has some really cool functionality for audio processing and also audio synthesis, so generating sounds kind of from scratch or from a set of notes and synthesizing them. So this one, so the sequence of the human gene. I don't know too much about genealogy and DNA science and that sort of stuff, but I know that genes are made of base pair. Genes are base pair sequences, which are pairs of bases, A, C, G, or T, and each one it's the first letter of a chemical, adenine, something. I don't know. I'm not good at biology, but so getting the sequence of this human gene. And there's a handy computable data function, genome data, here that can get you the sequence of a human gene, and then string take here is they're just getting those positions in it. So I'll copy that, and we'll see what that gives us. Delete all this stuff. Sequence equals this. Let's see. Sequence. Okay. It has to get data for the whole gene down to the computer, and then you get that sequence of values out of it. So it's talking to the cloud right now. Let's see what else they did while we're doing this. String cases. Oh, okay. That's slightly different from how I would have done it. Okay, so. Fortunately, they haven't moved forwards too much. They're on question 6, which is the next question. Last question was the gene music one, which my computer. What happened was it shut down due to low battery, even though I've had it plugged in for the last 2 hours. So don't know what's up there. I'm gonna just go bring up the chat here. So I can see myself in the chat. If there's anything. Okay, well, if there have been any questions while I was away, please ask them again so I can see them here. Okay, so yeah, they're on question 6, which is Pi Walk. Find the city closest to the endpoint of the geodesic path, starting at the coordinates of Waltham, city in Massachusetts, which is where we are right now. A geodesic path that for each digit with value n of the first 400 digits of pi, so each digit of the first 400 digits of pi, and assuming each value of those to be value n, and those are the digits following the decimal point, move forward in your path 5n kilometers and rotate clockwise to bearing n divided by 0.025 degrees from true north. Return a city entity. And here it's we can consider using some of these functions, so like a sort of word bank here. Geodisplacement, geoentities, geodestination, geonearest, and geodistance. So let's break this down a little more. Geodesic path, that's what I was talking about earlier, which is a path that follows the surface, the curvature of the Earth, as opposed to like a Cartesian grid, on a flat rectangle surface. It's so instead of the distance like on a map project. Okay, but the distance across the curvature of the Earth. That's the fancy name for that is a geodesic distance, geodesic path. So starting at the coordinates of Wolfram, then for each digit. So we're starting at a point, and for each digit, so 5, 3, 1, 4, 1, 5, 9. So we're starting out at the 1 after the decimal point. So we start with the 1. So we're going to move forward 5n kilometers. N is 1 in this case, so 5 kilometers, and rotate clockwise to bearing n divided by 025 degrees from true north. Now I happen to know that for this question, n divided by 0.025 is so that n, like, that's so there's a full range of 0 to 360 or 0 to 359 degrees. So that's not quite right, Waltham. Same distance, same place we started. So it's a little complex there, 0.025, which seems arbitrary, but it's so that 1 divided by 0.025 should give 1/360th, and then 9 divided by well, it's n divided, well, let's see, hold on. 9 divided by 0.025. Oh, okay, 360. There we go. So 9 gives you 360, and 1, okay, not 1/365th, but 1. Okay, 1 divided by 0.025. Actually, it would be 0, so that gives you 0. So actually, there's the range there of 0 to 360, and 360 degrees is 1 degree over, or 360, okay, 360 is 0 again, so, okay, whatever. So it's in increments of 40 degrees, so you get the full movement there. So move forward 5n kilometers, and rotate clockwise to that, so n, we were doing 1, so that would be 40 degrees from true north. Now, this is kind of the key point here, because you might be familiar with a function called angle path, which is very, very cool, and you can create very cool looking stuff with it. Angle path. So angle path is kind of similar to what we're asking for here. Okay, so you can give it, there are a couple ways to call it, but you can give it a list of, this is what the most similar to what we're doing. R, which is the distance to move, and theta, which is the angle to turn. But the difference between angle path and what we're trying to do here is angle path is relative. So for an example here, if it's starting at, I don't know which of these is the start, but if we're starting here and we move, okay, this one's the start. So we move here and then we move 90 degrees. It's 90 degrees relative to the direction that we're currently facing. So we moved here, or we moved 90. I think this is the start. But anyways, it's relative to the direction that we're facing. So if we move here and we want to move 90 degrees from here, we're rotating 90 degrees relative to that direction, which is this. And then here, up here, I don't know what that angle is. It looks like 45 degrees. I'm not sure. But again, it's rotating from that direction there down to there. So angle path works relatively, while what's being asked for here is a bearing. And a bearing is that thing which is moving your relative to an absolute value, relative to true north. So even if we start here and we rotate x degrees from a true north, however many degrees, go down there, then the next time we're rotating here, we're still facing, go down here and then we're still facing true north, and then calculate another displacement, angle displacement there, and move to a different place. So there's a difference, and I expect some people may have gotten tripped up on this, and the reason for that distance is because of these functions, geodestination and geodisplacement. These are a little lesser known. I actually didn't know about them before I saw this question. So, whoa, look at that. Quebec. I don't think Quebec is a city. Is Quebec a city? Yeah. Oh. Quebec is a city. Okay. Anyways, so geodestination and geodisplacement. Geodisplacement is a... Wait, okay, this is geodisplacement. Geodisplacement is a symbolic representation of rotating, of a displacement, a movement in a of a certain length in a certain angle. So it takes here a distance, the length to move, and an angle, which is, as it says here, bearing, and as it says down here, bearing is measured clockwise from true north. It can give it as a quantity angle or just a number in degrees, which is a little simpler. And we can see here that this one's asking for clockwise from true north. So it's written with geodisplacement in mind. And as far as I know, it would be more difficult to do it relatively, because you have to, if you want to still use geodisplacement, you have to keep track of that that sort of the tally and the relative direction. You could do it, but that's not what the question is asking for. So as I said, geodisplacement is a symbolic form. So if I just evaluate this geodisplacement thing right here, I'm going to get a geodisplacement, because it's just symbolic. It doesn't actually have it doesn't calculate anything, and that's because there isn't you can see there isn't a position in here. It's just a representation of that displacement, of that movement in a certain direction of a certain distance. So you pair that with geodestination. Geodestination takes a position and then applies a geodisplacement to it, and gives you the endpoint position from that. And you don't have to just give it one position, one displacement. You can give it, this should show here, yeah, you can give it a list of displacements. So you can generate a sequence of these symbolic displacement objects, and then feed that into geodestination. Just give it one start position, and it'll follow each of those and figure out the endpoint. Okay, so now we have an endpoint. I'm just gonna maybe steal someone's code from here. So let's see what this geoposition. They put something explicit in here, but an absolute coordinate geoposition. But this one asks for a Wolfram MA, and which is actually the entity itself is provided here in the question. And then here are these geodisplacements. Can you give geodisplacement a list? I guess you can, since they did it. Okay. I'm not sure if you can give geodisplacement a list, but in any case, you could map it across. What's going? Oh, okay. So that's interesting. Okay, I'm going to do this how I would do it. So I would do real digits here. We have fractional. We have pi here. So and we want to get pi is 314 la la da da da. And if I did real digits, 400 digits of pi, and that's base 10. That one there is. Another way to do this would be n pi 400. So anyways, what we get from this is the digits. Real is a fractional value, so not just an integer. So this is the digits of that number, the expansion, and we see here 3 is the initial digit. So it gives that sort of all in with these, and this is saying starting, where is it? Following the decimal point. So we want to get rid of that. We could use part to ask for because real digits also gives this thing at the end, which is if you ask for something like 1 divided by 3, it would tell it's the period of the repetition if there's a repeating decimal, repeating decimal real value. So I want the first list from here, and then I want starting at position 2. Lists are 1 indexed in indexed from 1 in Wolfram language. So I want to start with position 2 and then go from position 2 and on to the end. So that would give me this trim with that trimmed off. But another way to do it, and probably the more elegant way, is fractional part. So pi, let's look at n pi 400. So we start with that 3.1. If I use fractional part and apply it to that, it'll just give me, it's like pi minus 3. Or if it was something else, it just gives you, it's still a it's still a real value, so it's starting. But it's just the integer part is 0, and then it just gives you this fractional part here. And if I put that into real digits, it does not give me that leading 0, which is what I want. So I don't want the leading 0. So if I put that into real digits, then it'll give me this thing I want, starting at that 1 there. So I can just, it's actually, it's shorter to do that thing with part, but this is probably the more idiomatic, arguably more elegant way to do it. So I want position 1 from there, from that list, and then I have order of operations, right? Oh wait, no, what did I do? Oh, I didn't do real digits. There are real digits. That okay. So D is digits. Define it right here. Okay. So now I have those digits, and I want to create a bunch of geo-displacement objects, symbolic representation objects. So geo-displacement takes a list, which is, maybe you can put a list of lists into it, but I'm gonna do it the map way. Takes a list. First element is the distance to move, and the second element is the bearing to move from true north. So I'm going to map this, where when you're doing map, this pound sign here, the hash, is means the value. If you're mapping across a list, that for each element in that list, this thing will be applied to it with the value of that element in the list as hash. So I'm doing hash here, and I want to do the distance is, they're on to the next question, but I remember this, it's 4 times that, so this times 4. I hope it was that, I hope I got that right. 4, and then the bearing is this time divided by 0.025. And then I need this and here when I'm doing what's called a pure function, is what I'm mapping across, which is sort of it's like an ad hoc function, without actually, it's like an anonymous function is what it's called in some other programming languages. It's a function without a name. You're not assigning it to a named variable or a named identifier. It's just sort of chunk of code, which is useful for when you're mapping, because it's not necessarily, when you're mapping, usually it's, well, okay, a lot of the time it's not something, it's a waste to define it to a function name, assign a name to the function, and then use it in the map. So I'm using this, this sort of goes with the ampersand goes with the pound sign. So, okay, I'm going to map that across the digits, and I should get a bunch of geo-displacements. So 4 kilometers, 40 degrees. Oh, that reminds me, I need to use kilometers, so I need to say quantity, and this is the quantities and units I was talking about earlier. So this, the first element, first argument here is the magnitude of the quantity is what it's called. There's a quantity is made up of a magnitude and a unit, and the magnitude is the number, the integer part. So like 5 kilometers, the magnitude is 5, the unit is kilometers. So this is the magnitude here, the number of whatevers I want to move, and then the unit is kilometers. So then I should get geo-displacement of, doesn't that look like a, oh, wait, no, well, like, if that's a number, then, okay, I'm not sure why it's showing up as as an integer in there. That's a little weird, but, okay, so geo-displacement is simplifying it because it can take just a number in meters, so it's, for whatever reason, just converting it to meters instead of dealing with the quantity. Same thing, same result either way. So now I have these displacements. So assign that to a variable, that list here, and now I just want to city here and or not city, pause, equals geo destination of the first element here is Waltham, So the city I want to start with Waltham, and second argument is this list of displacements. So this should give me a geoposition, I think. It's probably doing. Wait. Okay. Oh, it's the whole. Okay, it's doing the whole path. Yeah, that's reasonable. Wait. Okay, it's each of the paths. Each of the points in this path is so the endpoint of each displacement. It's giving that in a list. So then if I is there a way to get the? Oh, well, it says it should do the last one, starting from. That's interesting. I thought there were. Maybe, okay. Oh, so okay, I guess I was wrong. Geodestination can't take a list, but then geodisplacement can take a list. That's interesting. So, so I'm just moving this in here, so I'm making a list of these kilometer degrees things, and then feeding that into just one geodisplacement thing, so it represents a no, okay, that's not allowed. Okay. So that's not allowed. So why is geodestination giving me a list instead of just the endpoint like they show here? Maybe I have to nest it. I thought there was a nicer way to do this. But whatever. But this thing here that is each of the displacements, I think. I mean, I guess I'll just get the end position from that. It's a little odd about that. What? Entry Waltham. Oh, okay. So they want the position of Waltham instead of just the city. Okay, there. So I get a geoposition, and now geographics. I guess geomarker of a. That just takes a location. So let's see where that is on the map. Hopefully that. Okay, that's. So it's in Boundary Waters Canoe area, somewhere in Canada, I guess. So now we have that position. They wanted the nearest city to that. So we can see there's question isn't here anymore. But there were a couple functions recommended. Some of those were like red herrings that assigned to. So it's not just feeding you the answer, the functions that you need, but there are some that aren't relevant or aren't as relevant. But geonearest is the so geonearest is a function that finds the geographic entity of a particular type that's closest to a location. So if I give it a location and for the entity type I give city, it'll find the city that is closest to that location. So I'll just say the first argument is city here, and then give it the position, and hopefully Slim Lake. Now I seem to recall that might. There's the. Maybe I did something wrong here. That's entirely possible. That might be the second to last displacement because of what this is looking like. I thought that geodestination would take a list of displacements. Okay, that's interesting, but this is good. This is live debugging. Geodestination. These do all show using just a single displacement, but I think you can do it with multiple displacements, or at least I thought. I should probably hurry up now because they're on another question. Okay, I'm 2 behind now. Okay, let's just skip ahead. I don't even know what the answer that came out of this was. But There's probably an answer. Oh. Well, first, oh, that's an interest. Okay, so it's actually if you use that n pi, it's the first 399 digits after the comma. Okay, that might be a lack of clarity in the question then. So how are they doing all of this? I don't want to figure out this thing, but this is okay. So this one is nesting. Is that the right way to do it? Seems like you shouldn't have to nest. Okay. Well, I'm gonna skip ahead and to the next question, which is not even this one. I do have them over here, so I'll grab it. This next one, question number 7 is a simple one. At least I think I have it over here. Hold on. Okay, question number 7. Okay. Reverse the characters in place of all single-word nouns in this text as given by text cases. Return a string. So the text given is the Gettysburg Address as retrieved from example data. So that one's its text and Gettysburg Address. So put that on a variable. It's the usual 7 years ago. So yeah, that's it. Okay, that's that. So this one's kind of more simple, but we're reversing in place all of the nouns. So I can do text cases, which is it's kind of a special smart function in the same vein as string cases. String cases takes a pattern, while text cases takes not exactly an entity, but a unit, a chunk. So you can give it something like, I could say text cases, I believe I could say text cases sentences to get all the sentences, although there's actually a function called text sentences that does the same thing. But then I can also say text cases noun. So everything in that text matching this particular type of thing. So I give it the text and then I give it the form, that's what they call it. And I can give here noun. So cases, I'll see, because for cases is the cases of noun in this, and I'll actually the semicolon, and then once that's done, see what the is. And this one, I believe, since it's a lot of the smart natural language processing functions involve calling out the cloud, so that takes a bit. So score, years, fathers, continent, etc. So these are the nouns, and there's some of them probably that are like remember. That doesn't seem like a noun, but the fact that it's giving it as a noun means that there's some obscure definition of remember. Probably this still involving remembering, but just there is a definition of it. It can be used as a noun. Okay. So I have these text cases. Now I'm going to do string replace part. I think that's right. Yeah. So I can replace. Okay. Well, I have text cases. Maybe I just want to. Actually, I think I just want to do string replace. So with that string, I'm replacing. I want to make rules for these cases. So I want to replace each one with it reversed. So to do that, I'm going to map. I'm going to do a map thing. So a rule looks like a thing to replace, an arrow, and then the thing to replace it with. And rules, you also see them in. And this is a rule for replacement. Rules in general are also used in associations with that arrow. That's each element of an association is a rule. So for C, I'm gonna map across it pound, which is, remember, the value, each of the elements of C, pound arrow, so it turns into, it's replaced by string reverse of pound, so the reverse thing. And then again, I need my ampersand and map that across. The ampersand indicates that this thing before it is a pure function. So here we have a list of rules to replace. Some of these might be duplicated because like nation and nation, because Abraham Lincoln used the same word twice in the speech. That's understandable. But a string replace isn't going to care since it's only going to replace it once. So string replace, I have these rules here, and I'm just going to put them into string replace, and that should give me 4 Erox and 7 Surrey ago. So that's the answer. That's the result. So okay, that's that one. And again, if there are any questions, you can ask them in this chat thingy. Okay, now the one that they're currently on to, text edit distances. This is fun. So sort the given list of languages, which is looks like the list is not appearing there, but I guess they sorted it out. These languages here. Oh, that's interesting. Distance matrix. Okay. So sorting these languages in ascending order by the edit distance of the language's translation of the United Nations Universal Declaration of Human Rights from the same text, the same version of that, the Declaration, in English. Use example data to obtain the text and return a list of language names and strings sorted in ascending order. So edit distance. What's an edit distance? Edit distance, so also known as edit distance, is the Liebenstein distance, which is the number of changes required, number of single character changes, specifically the number of one element, or you can use it on a list, not just a string, but one element or single character deletions, insertions, and substitutions, so changes, character changes required to transform from one text or one list to another text or another list. So let's first get our text here from example data. Let's see, example data. So it would be text, and then UN, human rights. The reason it's all these languages, these are all the translations that are in example data. Human rights, English, because we're going from English. So we have, actually, instead of T, that should probably be like ET for English text. And that's just, it's a pretty big chunk of stuff. But then we'll get each of the translations. So I'm going to do something. I could like map across example data to get each of those translations. But because I want to know the language that corresponds to each translation, I'm going to make an association with association map. Association map takes a list. It's like map, but instead of mapping across that list and then returning a list as return, it returns an association where the keys are the values of the initial list and the values of the association are the mapped results. So association, if I were to just example data, text, UN human rights, and then string join, so concatenating that with the pound here, the value, the slot, that's what those are called, the pound, that is, and then map that across the, I need the list of languages, don't I? Which is here. And it was in the question, so it should be given to the contestants have that list. It's supposed to appear up here, but it didn't. So map that across languages. If I just mapped it, I'd get, it's downloading all the translations here. Once they're downloaded, they should be cached, so it shouldn't take as long. Okay, well, I'll start writing my next piece of code. There it is. Okay. Oh, it's a big thing here. Oh, okay, I guess I should show that. Okay, so it's each of these, it's mapped across this. So the first one is Chinese, so that's the Chinese translation. But it's just the text, but we don't know what language each text corresponds to. So association map is, as I said, it's just like that. I can copy verbatim my my pure function here and put that in. But what I'll get, and I'm going to assign that to a translations. What I'm going to get from that is an association where the keys, hold on, the keys are the language name and the values are the translation. So now I know which language corresponds, and my code knows which language corresponds to each translation. Okay, so now that we have that, we want to get the edit distance. So edit distance, I'm going to, if you map across an association, it treats it as if it's just mapping across the values, the list of values in that association. But then the result it gives you is the full association, but with the values replaced with the map results. So that's if you just map across an association object. So it's useful it maintains the keys exactly as they are, and the map pure function that you're using doesn't know what the key is. It's just dealing with the values. But you still have the key. So I'm going to map this edit distance. And so it takes the first one is this is ET, the English text. So the edit distance from English to that pound here, that thing, and map across that translation, and map across the translations. So distances. It'll take a little bit because edit distance is a pretty complex thing to do. It's figuring out every change, but it shouldn't take too long. Are they? Okay, they're still on this question, so I'm not far behind. Let's see. Text edit is an interesting function. I don't think there is a text. Is there a text edit function? No, I don't know of a text edit function, so I'm not sure what you're talking about there. Text. Edit distance. Edit distance. Yeah, edit distance. You're right. Edit distance is a very interesting, very interesting function, and it's a pretty complex thing that it's doing. So it's useful. I thought this wasn't going to take quite so long. But okay, let's see. Still going. Okay, that's very odd. I thought are they doing it differently here? No, they're doing the same thing. I'm not sure why that's taking so long. I'm gonna just, yeah, it's each of the translations. That's weird. That's taking a while. But let's limit it just for this because it's taking so long. I'm going to limit it to the first 5 translations. So the first 5 thing. Oh, they're doing prizes on the mainstream. That's cool. Maybe I can show the prizes here afterwards. Yes, there are prizes for the winners. But don't leave here. Stay here, please. Or you can open up the mainstream in like another window, which is on the Stephen Wolfram's account. The Stephen Wolfram Twitch page. Okay, there we go. We have distances. So what this is it's pretty simple. It's the edit distance, so it's the number of those one-character changes required to move from English to Chinese, or to Danish, or to Dutch, or to Esperanto, or to French. Now, we don't have all of the languages in here since it was just this thing. And they wanted to sort it in ascending order, so that's not reverse sort. Since it's ascending order, it's just the sort function. Sort this, and then, so this is in ascending order by that, and then I just want the keys from that association. So discard the values. So Esperanto, French, Danish, Dutch, Chinese. So it's actually kind of interesting because for stuff like Chinese, there are no common letters between except for maybe some proper nouns that they don't translate, but there are no letters in common between the English version than the Chinese version, because Chinese has a totally different character set. But this result actually does make sense. Esperanto, French, Danish, Dutch, Chinese. Esperanto is a human made language. I mean, like a constructed language. People actually thought about how to construct it, and it's a blend of, I believe, pretty much like all the Romance languages and English. So I don't know that much about it, but it is probably the closest out of these languages to English. And then French, Danish, Dutch. French, that's another Romance language. Danish and Dutch, I believe, are both Germanic, and English is a conglomerate of weird mishmash of Romance and Germanic languages. So it actually does make sense. And if we scroll up here, we can see someone else's results, like Esperanto, French, Danish, Spanish, another Romance, Swedish, that's Germanic, I think. Yeah, Swedish is, I think that's a Germanic language. It's at least, it's around there, like Nordic. Latin, of course, Romance. Swahili, I don't know what's up with that. I have no idea what Swahili looks like. But a lot of this actually makes sense. So it's a kind of interesting result that we get from here. So okay, that's that. Looks like they're still on this. Let's perhaps we'll go over and see what they're up to.
Yeah. Okay. So there are 3 prizes here. The first prize is something that was created for our.
Oh, okay. I'll show these to you then. I'm going to show these. I'll get them back here. Hold on a sec. Okay, maybe I'll be able to show them a bit later. It sounds like this is the last question they're doing. They're wrapping up now. So I guess I'll just go over, if there aren't any more of these. If there are any questions, please feel free to ask in chat. And I guess I could go back to the Pi Walk one if you want to see the completion of that. But I can bring up. Oh, I should supposed to be on here. Hi. I can bring up the Stevens stream just on here, so I'm sort of rebroadcasting it with the audio, if that's interesting. I guess I'll bring it up over here.
Since 1988. Okay. Well, anyway, and when the need for computational intelligence arises, look no further than this text. Yeah, what a fine concept. Yes, right. Well,
this is okay. This is what they're discussing right now. Is the prizes. The first place prize. The first place prize is a Raspberry
Pi. Description, because usually these are Lego pieces that are
a Raspberry Pi computer and a limited edition Tech CEO minifigure. So similar to the ones that are produced by Lego, the little minifigure, limited edition. It's certainly not modeled on anybody we know, definitely not, nobody. It's limited edition, produced by Wolfram, and no, I'm afraid you can't buy it, at least not yet. I have a picture. I'll bring up the picture.
Awesome features. A new kind of.
It's this Tech CEO. I have here. I can some pictures of it standing here, and there's the back. A new kind of CEO, inventing the computational future since 1988, and here, and yeah. So that's prize number for first place. They get that and a Raspberry Pi. Second place prize gets Raspberry Pi, and the third place is, well, a Raspberry. We got a Raspberry. You figure the second place gets the Raspberry Pi, subtract the Pi, and it's a Raspberry. So the third place result gets a Raspberry. Okay, so it sounds like there's a tie, and they're probably going to go to the tiebreaker problem. So this, yeah, okay.
Different people had at least one solution within that came in the first three. Okay. So we have a tie for fifth place between Meng Yi and Zhu.
Stand up.
Yeah, applause. What is it? Oh, okay. Yes. Okay, good. Okay, we have a four-way tie between fourth place, a four-way tie for fourth place, and all those people got placed twice in the top three, and those people are Carl. Well, we should hold the applause. We get all four people together. Carl, right? Carl, and then FFF, 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 FFF. And also Lanston Chu and Keminator. Very good. Okay, in third place, sharing the third place raspberry, complete with, I don't know if this is really a sanitary operation. I mean, we should give consolation. Oh dear. This really won't work well. Wait a minute. This raspberry had a paper clip inside it.
We were trying to make it stand up and look important.
This is okay. We've got some consolation raspberries, I believe. We have some extra fruit, I think. We should provide consolation raspberries. Okay, so and raspberry halves go to Maxit G and Terminate. Okay, very good. I don't know whether we can really. I'm not sure this is worth presenting. I don't know what. No, we got to have a. Yeah, we should. Yes, right. No, you don't want to eat it. Don't want to eat it. No, don't eat it. Don't eat it. It's these.
Save the seeds and grow raspberries next spring.
We don't want any kids. Maybe wait, can both of you hold it?
Yes, both hold it.
Yeah.
Okay, so I'm gonna just leave this up, and I'll pop back in here if they make it to the tiebreaker problem and commentate on that. Okay.
So I should say, by the way, that both these folk got 5 points in our scoring system, and okay.
It's like a wishbone.
Oh, well done. Oh, great. Okay, so in second place with 7 points, the winner of the more useful raspberry pie is Total Annihilation. Aha. Ta-da. Do you already have one of these or not? Oh, sure. Oh, no. Okay.
Oh, you can set up another server.
Yes. He set up with Mathematica on a Raspberry Pi earlier today that was running.
Oh, okay. So, all right. And the first place so Total Annihilation got 7 points, and the first place with 15 points goes to the Fox Goat. Oh no! Well, you know, I kind of had a suspicion about the identity of the Fox Goat. There's the Fox Goat. The Fox Goat is happens to be genetically.
How many kids can say they have an action figure of their dad?
So the Fox Goat turns out to be none other than Christopher Wolfram, and Fox Goat. You kind of get the fox. I didn't get the Fox Goat. As the
one who learned how to speak Wolfram language before English.
Well, okay. It's all right. Well, I think that's probably it for our live code.
Deadline by midnight tonight.
Oh, yeah. Well, so just for people on the live stream and for people here, we have this great homework exercise of writing a computational essay about something, and everybody here, we should extend this deadline. This is too late.
We could probably extend it.
I just want to make sure to read all these computational essays. So.
Oh, now we get.
Okay, Kyle is a professional educator, so he knows about stuff like this. Okay, great. Thanks for participating, everybody. Thanks for folks on the live stream.
Thank you, everybody, for watching. It's muted. I didn't. There was no tie for first place. There was a single winner. But I hope you learned something, and I'm going to play this video that they made that I didn't get a chance to do before, and then end the stream. Thank you. Okay. Bye.